Good afternoon, teacher. My name is Nicolas. Today I'm going to talk about the exercise 30.3, which is all about the evaporation of an ethanol film on an inclined plate. So here's the problem statement. We have a plate that's 2 meters wide and 4 meters long, and there's a thin film of liquid ethanol flowing down at 289 Kelvin. Now we have air that's free of ethanol, and it is blowing across the plate 3 meters per second. So what do we want to figure out is how much ethanol do we need to feed at the top so that it all evaporates before it reaches the bottom. This is the given data. We have the plate geometry, we have the film temperature, the air properties, etc. So we first start by figuring out the conditions in the gas layer. We take the average temperature of the gas, which is about 296 Kelvin. At this temperature, the diffusivity of ethanol vapor in air is roughly 1.37 times 10 to the minus 5 square meters per second. So we next calculate the Reynolds number and the Schmidt number. The Reynolds number here is about 30.9 times 10 to the fifth, which means we have a mixed laminar turbulent flow. And the Schmidt number is 1.12. Using these values, we applied a correlation to find the mass transfer coefficient, Kc. Here it is. This is the formula. And we get about 5.33 times to 10 to the minus 3 meters per second. This is the value of Kc. And with this value, before we use this value, we calculate the concentration of ethanol vapor, knowing that the vapor pressure and the total gas concentration. So we first calculate the mole fraction of ethanol in the interface. We use the pressure and the total pressure. After that, we calculate the total gas concentration, and with this, we can calculate finally the concentration of ethanol, which is 2.73 mole per cubic meter. So now we calculate the flux of ethanol vapor. Since the air has no ethanol initially, we just multiply the mass transfer coefficient Kc by the concentration of ethanol. We ended up with a flux which is about 0.0145 moles per square meter per second. Finally, to find out the evaporation rate, we multiply this flux by the plate area of 8 square meters. That give us roughly 0.116 moles of ethanol per second, which is about 5.3 grams of ethanol per second. So in other words, if we supply ethanol at the rate of 0.116 moles of ethanol per second at the top, it will all evaporate before it reaches the bottom of the plate. That's the exercise. Thank you very much.